All right, let's dive into one of the most, mind-bending questions in all of physics. This is a big one, because it gets right to the heart of what our reality is actually made of. So here's the fundamental question. I mean, look around you. Look at your hand, or the table, or the wall. Everything seems totally smooth and continuous, right? But what if it's not? What if, when you zoom way in, to the smallest possible scale, reality isn't smooth at all? What if it's granular, pixelated, kind of like a photo in your screen?
This is a perfect way to visualize the two options. So, on one side, you've got our normal, classical way of thinking about things. Space-time is like a super smooth ramp. You can stop anywhere you want on it. You can move any distance, no matter how tiny. But on the other side, you've got the quantum idea. And that's more like a staircase. You can be on one step, or you can be on the next one up, but you can't be in between the steps. There's a smallest possible move you can make. And then there's just nothing.
Okay, so if we're gonna even consider this, this wild idea of a pixelated universe, we've got to start with the pixel itself. What is one of these things? What are we actually talking about when we say a quantum of space-time?
This right here is the first huge question we have to tackle. Before you can build a whole universe out of these pixels, you have to understand the building block, right? It's like you wouldn't start building a house without knowing what a brick is or what it does.
And once you start asking, the questions just keep coming. Seriously, think about this for a second. How big is it? To even measure that, you'd need a ruler that's smaller than the smallest possible piece of space. How do you do that? What shape is it? Does it just sit there? Or does it change and evolve over time? Honestly, just answering one of these would be a Nobel Prize easy.
All right, so we've got our single lonely little pixel. But, one pixel isn't a universe. The really cool part, the magic, is what happens when they all start interacting. How do all these little pieces connect to weave the entire fabric of reality? And that leads us to this next critical question. It's not just about what these pixels are, it's about what they do. How do they link up with their neighbors to create the space and time that, we're all sitting in right now? There's a word for this. Physicists call it coupling. And you can think of it as, basically, the rule book for the universe at the tiniest, most fundamental scale. It tells you how these little quanta are supposed to connect, when they should let go, and how they interact with each other.
And I love this way of thinking about it. It's not just some dry, technical detail. It's more like the social rules of the universe. The etiquette of existence itself. It's all about how these fundamental bits and pieces behave when they're all packed together.
Yeah, so what this means is that we're not talking about some static, frozen grid. It's a constant, a cosmic dance. For our reality to work the way it does, these quanta have to be able to move around, to change, to form new connections, and, this is just as important, to break old ones. It's this constant linking and unlinking that makes the universe dynamic and, alive.
Okay, buckle up for this next part, because this is where our whole pixel idea smacks right into a giant observable fact about our universe, and it creates a really fascinating paradox.
Here's the fact. The universe is expanding. This isn't a theory. It's an observation. We can measure it. We see galaxies moving away from us and from each other. The space between them is literally stretching. The universe is getting bigger every second.
And that brings us to the giant puzzle. If our fundamental building blocks of space, our pixels, have a fixed size, if they can't stretch, then how in the world is the space made of them stretching? How do you get something that expands out of parts that don't?
This is the core of the problem, right? How do you reconcile these two things? The unstretchable building block and the stretchable universe we see all around us. How do you solve that? Maybe new pixels of space are just popping into existence all the time, filling in the gaps as everything expands. Or is it some totally different mechanism that we haven't even dreamed of yet? Figuring this out is like a top priority for physicists working on quantum gravity.
Which brings us to the last question, and honestly, this might be the most profound one of them all. If reality really is like a staircase, what's in between the steps?
I just love this question because it pushes us right to the absolute edge of what we know. It's literally asking us to define the space between space, to describe the properties of what? Nothing? Is it nothing, or is it something else that we don't even have a word for yet?
Yeah, when you start thinking about this, you're not just doing physics anymore. You are on the border with philosophy. Because if space-time is made of these little chunks, then that gap, that nothingness, that void in between them, suddenly becomes a real physical thing that you could potentially study. How wild is that?
And that's where we'll leave it, with a question that just kind of spirals on forever. You've probably heard of the turtles all the way down problem. Well, this is it. Even if we finally discover that fundamental pixel of reality, you know what the very next question is going to be, right? Okay, but what's the pixel made of? It's the kind of mystery that guarantees we're never, ever going to run out of things to explore.